From the beautiful northern studios of Way Happy, this is Mr. Meyer in section 2-2 proportions. Now, what is a proportion? A proportion is simply two ratios that have been set equal to each other. In other words, two fractions that have been set equal to each other. And then usually there's an unknown in there somewhere and you want to set it up. Like maybe you can make a proportion to represent something and you have a proportion that represents another thing and you're trying to compare those two as long as those two things are equal. So let's look at example one here. You can see right away that this is telling me that this right here, I don't know why I circled that. I meant to circle this proportion right here is equal to this proportion right there. So those two proportions are completely equal. And so for that to be the case, then I should be able to solve this by what we call cross multiplication. Cross multiplication says, hey, let's multiply these two numbers together and let's multiply these two numbers together and set them equal. Now this only works when you have a fraction equals a fraction. So when I do this letter A here, I'm going to do 16 times 12.9 is equal to 24 times P. I set one fraction equal to another, and now I can actually solve for our good friend P. Now I'm going to do 16 times 12.9, and I get 206.4 equals 24p. And then now I'm going to solve like we did last section. I'm going to divide both these by 24. And if I divide that by 24, I get the magic 8.6. And so that means that little p right there is 8.6. And not bad, right? Not bad at all. In fact, you can kind of double check your answer because proportions should kind of make sense. It is claiming that P 8 is half of 16. Well, look, 12 was half of 24. So that does make some sense. And I feel pretty good. All right, what about this other one? What about B? If I'm going to do B, I have the same thing. So I'm going to do this proportion. I'm going to cross multiply. I'm going to get 14 times 132 is equal to 88 times C. And so if I do 14 times 132, I get the magical 1848. And I have equals 88C. And if I want now, I can divide both sides by 88. They will cancel here. And when I divide that by 88, my calculator spits out a happy 21. Again, I try to make sure that makes kind of sense. You can see that 14 was a lot smaller. The numerator was a lot smaller than the denominator. And again, the numerator is quite a bit smaller than the denominator. So it doesn't tell me the answer is right, but at least tells me that my answer makes some sense. All right. What else could we tell you? How about example 2? A poll taken one day. Oh, there's the answer. A poll taken one day before an election showed that 22.5% of voters plan to vote for a certain candidate. Wow, what an appropriate question for this year. 1,800 voters participated in the whole poll. How many said they plan to vote for that candidate? So again, I can kind of set this up as a proportion. I can kind of set this up as a multiplication problem. There's a couple of ways I could do this. But I know, let's do the percentage on one side. So let's make one fraction that's the percent. 22.5 say they're going to vote for somebody out of 100% total. So there's like my portion that's going to vote over the total amount of people. That's one ratio. And then to make a proportion, I'll set it equal to the number of voters. Well, I don't know how many are going to vote for this candidate, but I do know the total is 1,800. So maybe you can see that the top represents, all the numerators represent how many people vote for a certain candidate, where the denominators represent the totals of those things. 100%, it would be a total of a percentage, and 1,800 would be the total of people we talk to. So now we cross multiply and solve. So I don't know, decimals are kind of weird. Remember, you got to move it over 2 spots. So I would probably make this 0.22, whoops, why isn't it writing? 0.225 over 1 is equal to x over 1,800. And then I would cross multiply this way, I get x. And this way, I get whatever the heck 1,800 times 0.225 is, or the 25%, which I bet a lot of people logically would have said, well, you just take 22.5% of 1,800, and that will get you your answer. And so as I do that, I get x is 405, and I can go, oh, yay, that's what it was supposed to be, because I see the answer to the left. So 405 people would have voted for candidate A, whoever that may be. All right, what about this one? Let's do another proportion. Ryan ran 600 meters and counted 482 strides. How long is this stride? So I'm like, piece of cake, right? I know he ran 600 meters in 482. There go technical difficulties again. In 482 strides, right? That's what I know. Well, I'm going to set that equal to how many meters then is one stride? And I'm like, yeah, I'm golden. Get my calculator out. I get 482 times x is equal to 600 times 1. I'm going to bring that 482 over. So I'm going to get my calculator out. 682 divided by 400. And I get 1705. So x is 1.705. But wait, I was in meters. And that's why units, yes, they are important. Those are meters. So now I would like to know how many inches that is. All right. So if I'm going to do that, I am going to convert that. Wait, I just got a different answer. What is 600 divided by 482? I got 1244. You guys following along? I don't know where I got this number from. But as I was retyping to double check, I got 1.2448 meters, which makes more sense. 1.7 seemed kind of a lot, like a guy had a 2-meter stride. I thought it was a little weird, but I was double checking, and now 600 divided by 482 does give me 1.244. I feel way more confident. All right, that's how many meters his stride is. Well, now I'm going to say, all right, 1.2448 meters is how many inches? I don't know, but I do know that 1 meter is 3937 inches. So a little conversion there, right? And that, since those two things are true, I know 1 meter is that many inches, that I should be able to convert 1244 meters into X amount of inches. And now again, I will cross multiply, or really you might see that I'm just multiplying by 3937. And when I do that, I get 49.008. So X is 49.008 inches. All right, that is some beautiful mathematics, and we will come back after this short break. All right, nice work. Now let's try this next one that says triangle XYZ. Oh, there it is again, your beautiful geometry. Triangle XYZ has vertices 0, 0. There's X. I guess I should have put the X in the front. And -6, 9. So I'm going to go here. Well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. That is Y. -6, 9. And then 0, 9, which is right here, is Z. So I graphed them all, and there is your beautiful triangle. And if you want, you can kind of make a triangle out of that. You can see my lines are beautifully straight. So life is good. All right. So now that I got that all done, I'm going to then figure out that there's a similar triangle, which we'll draw in red. And it has a vertex 0, 3, and that's B. So 0, 3 is right here. That is B. That is 0, 3. Now, little heads up. Look at the order of the triangle. We went X, A, B. And on this one, we went X, Y, Z. So X to Y to Z, right? X, Y, Z. And now we're going X to A, which has got to be sitting around here somewhere, to B. That's the similar triangle. So now we just want to figure out where the heck is that point. Well, we could guess, but nobody likes to guess. I'm guessing it's something, comma 3, if that helps you any, because I saw that this was straight across up here, right? And then this, what is that symbol in geometry? It's like a arrow like that. And so those have got to be parallel. So thanks to geometry, I know it's something, comma 3, but I want to know what that something is. Well, these are similar triangles, right? These are proportional. So I should be able to set up any proportion. Like, let's talk about this long side right here on this triangle. We know that that's 9 units. And we know that this shorter side is, what do we got? 6 units, if you count it. And that should be equal to our little triangle, who will have this little guy who's only 3 units, but he represents the long side. And the shorter side, I don't know. So I'll call it X. And because of those proportions, I should be able to figure out that short side. Quick multiplication, what do you get? 9x equals 18. So x is 2. So that means that the coordinates, this must be 2, but it was left 2. So it must be negative 2. So I got to be careful about little things. And there you go. Negative 2 comma 3 is the vertex for that last point. So I could give you all the points. It said graph them on the same grid, but I could tell you exactly where that point is. And lo and behold, we have figured it out with a little bit of logic and a little bit of math. All right, last but not least, here's your last one. The tree in front of Luca's house casts a 6-foot shadow. So she has a tree. I mean, she has a house actually, and she has a tree, and that's my tree. And then let's make some shadows. The tree has a 6-foot shadow, and at the same time, the house casts a 22-foot shadow. So 22-foot shadow from the house. Guess that was the house. And if the tree is 9 feet tall, how high is the house? Ooh, what a good question. But again, do you see the similar triangles there? Do you see I could set this up again as shadow over height? So I'm going to go shadow over height of the tree, and you could pick any way you want as long as you're consistent. Now I have to, because I did shadow over height, I have to do shadow of the house over the height of the house. I can't switch that up, right? Could have done it the other way before, but now that I've picked, I got to stay consistent. So the shadow is 22 feet. The height of the tree is x, so boom. What do you got? 6x equals 22 times 9. So 22 times 9 is a mere 198. And 198 divided by 6 is a mere 33 feet. And you jump up and down. You know that her house, Luca's house, is now 33 feet tall. That's it. Have a great day. Stay happy, and I'll see you tomorrow.